Today we will look at combinations. Tomorrow we're going to look at something called the binomial theorem. The interesting thing about combinations is the problems seem more complicated, but the solutions are usually easier. And I mention that because I want you to get this into your head. Don't overcomplicate things with combinations. It's very easy to overthink things and think that the work involved to get an answer is more complicated than it really is. So today we're going to learn how to solve problems using combinations or involving combinations. As a warm-up to illustrate the difference between a permutation and a combination, let's talk about four people. Alan, Betty, Charles, and Danny. And I hope it's not lost on you that this is A, B, C, and D. It's a nice set of names that we can abbreviate. In what way is selecting a president, vice president, and secretary from that group? So we have four people. We need to choose a president, we need to choose a vice president, and we need to choose a secretary. How is that different than this thing? We want to select 3 judges in a magic show contest. The number of ways to choose the 3 judges is going to be a different number than the number of ways to get a president, vice president, and secretary. Why? I think this might be a case where intuitively you understand that that's going to be the case. But why? Who can tell me? I'll even go one further and tell you there are going to be fewer ways to select the 3 judges. Jeff?
Instead of selecting like 3 different jobs, it's all working in one option.
Right, the judges are all the same, right? So if I choose these 3 individuals, everybody as the judges, that's the only way I can choose these 3 people as the judges. If I have the judges sitting at a table in front of the performer, it doesn't matter where they sit, does it? Because they're just 3 judges. But when we talk about president, vice president, and secretary, if I have these people being, these 3 individuals as being president, vice president, and secretary, president, vice president, and secretary is different than this person being vice president and then secretary and then president. You get my drift? And I've chosen this as an analogy because what we can say is that president, vice president, and secretary are positions. And the word position here has a dual meaning. Position could be where they are in a list, or position can be what their title is. So in the end, getting 3 judges is just getting 3 judges. These are positions, so order is important. You can imagine it being that this is president, vice president, and secretary of the school student council, and they have a council meeting room, and the president has a nameplate engraved into the table, and the vice president has a nameplate engraved into the table, and so does the secretary. So Alice being, I keep saying Alice, Alan being president, Betty being vice president, and Charles being secretary is not the same as Betty being president, Alan being vice president, and Charles being secretary. So order is not important with the judges. This, by the way, illustrates the fundamental difference between a permutation and a combination. The number of ways to get a president, vice president, and secretary will be a permutation because order is important, like a phone number or the arrangement of algebra tiles. However, getting the 3 people as judge, 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 the number of ways to do that is referred to as a combination, like cards in a poker hand. Doesn't matter the order in which I hold them. So what I'm getting at here is that ABC is different than BAC. I'll go back to this. ABC is different than BAC. If I use what's above here as a code, president, comma, vice president, comma, secretary, ABC is different than BAC, but over here, this is the same. When the magic show starts and the judges take their seats, they're just three places that say judges. Doesn't matter where they sit. So, in the first case, Alan is president, Betty is vice president, Charles is secretary. In the second, Betty is president, Alan is vice president, Charles is secretary. Whereas here, they're judges. You get the drift here? So, the number of ways in which we can select president, vice president, and secretary can be figured out. Since it's a permutation, we can just take a shortcut and say 4p3. You could use the fundamental counting principle and say this is the president, this is the vice president, and this is the secretary. How many different people can you choose for the president? 4. For the vice president, you're down to 3, and then down to 2. And you can confirm that that's 24. Are you with me on that? So here they are. Here are all 24. And once again, I've listed, just like we did yesterday with repetitions, I've listed all of the ways to do the thing. And this time I've given you that list. So these are all different. If we focus our attention on this, Betty is president, Charles is vice president, Alan is secretary. If we focus our attention on this, who's D? Diane? Danny? If we focus our attention on this second one here, this DAC, Danny is the president, Alan is the vice president, and Charles is the secretary. So these are all different. Now, the question becomes, if we use this list to determine how many ways we can just choose the judges, how many ways are we going to get? And it's a really simple question. You probably don't need a list to figure it out. It's going to be 4. And the reason is, the thinking is, if you have 4 individuals and you need 3 judges, one of these people will not be a judge. So you can either have Alan sitting out, Betty sitting out, Charles sitting out, or Danny sitting out, and there's only 4. But if we take a look at this list, I've arranged this list in such a way so that that top row is really all the same people. If you look at that entire top row, it's A and B and C somewhere in each grouping. So Danny is not anywhere to be found there. And in this one, I guess it's Charles that's absent. And in this one, it's Betty. And then down here, it's Alan. So each of these rows is really only one group of 3 people, one combination of 3 people. So the answer to the question becomes, if we go to judge, 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 and you don't have to rewrite this. I mean, this is just, we're in a learning mode here. Those are gone because we've got them here. Those are gone because we have them here, etc. So we whittle this down to only 4. There are 24 arrangements of 3 items out of 4, but there are only 4 combinations of 3 items out of 4. This, by the way, and we'll get to the notation in your notes in a second, but this problem, by the way, if I go back to here, well, we already have it written down. I don't think I need to do this, right? This is written as 4p3. That's how many permutations of 3 items out of a group of 4 are there. When we take a look at this, where we get 4, we write that as 4c3. It's the number of combinations of 3 items out of a group of 4. So 4p3 rather, is 24, but 4c3 is only 4. So let's get back to the point here. The number of arrangements of 3 items out of a group of 4 is 24. The number of selections, which are called combinations, of 3 items out of 4 is only 4. What can you do to the number of arrangements to get the number of combinations? What can you do to 24 to get 4? Now, I mean, I think intuitively you know the answer is not minus 20, right? All the stuff we're doing here has to do with multiplication. So the bottom line is to go from 24 to 4, we can divide by 6, but that's 3 factorial. And it's no coincidence that 3 is the number of items you're either arranging or choosing. The number of combinations is always going to be fewer than the number of permutations. And to turn it around maybe, to make more sense of it, the number of permutations will always be more than the number of combinations, and it will be the number you're choosing factorial times more. So when selecting a group of individuals from a list and the order in which they are not selected is not important, we're finding combinations. Whereas if we're finding arrangements of those items where order is important, we refer to that as permutations. And what we learn out of this warm-up is the following. That if you take the number of arrangements and divide by r factorial, you will get the number of combinations. So if I said to you that there are 8 people in the room and I want to choose 3 of them to take for ice cream, it doesn't matter the order in which I pick them, it doesn't matter the order in which they order the ice cream, it doesn't matter the order that we leave the classroom. It's a combination. What I can do is I can find 8p3 and divide by 3 factorial. And it doesn't have to be 3, obviously. I've chosen an example without thinking that is also choosing 3, just like the 3 judges. It can be 4. It can be any number you want. This would be kind of a cruel thing to do, to have 8 people, and I'm going to pick 7 of you to go for ice cream, and the other person's going to be left behind, sitting all alone. But I could do that, couldn't I? Okay. Well, we know how to calculate NPR. And I'm just going to write this out. You don't need to because it's going to be in your notes on the next page. Don't turn just yet. We could make a formula for NCR because we know NPR. We know that NPR is n factorial over n minus r factorial, right? We just have to divide this by r factorial so now we get a formula for NCR. It looks like the formula for NPR, but there's that extra item on the bottom that says r factorial. And now you can turn the page. I just didn't want you to look at this formula and go, well, where did that come from? That is what you get when you take NPR divided by r factorial, which the warm-up taught us is how you find combinations. There's something else we have to talk about here, and it's just, it's a notation, that I can also write that. And this thing here is pronounced NCR. It's no different in pronunciation or meaning than this. It's just a way, for whatever reason in math, that people have decided to write NCR. So when you see those 2 tall brackets with 2 numbers inside stacked, the top number is n and the bottom number is the number you're choosing out of n. There is no equivalent permutations notation like this. So when you see this, it is a combination. We still have to apply the rules of and, meaning multiply, and or, meaning add, to be successful here. Examples. In how many ways can 4 students be selected to go on a trip out of a class of 15? This is what I mean by don't overcomplicate things. It's 15, choose 4. That's all you have to do. You have to say it's a combination. And that's the answer to the question. That's the answer to the question. If you want a numerical answer and you want to use your calculator and the formula, we can write 15 factorial over 11 factorial for factorial. And if you wanted to, although I don't know what would possess a person to want to do this, you can then calculate it by using the factorial notation over and over again. Or you could just cut to the chase and use your calculator by entering 15, choose, and this, I'm sure you've seen it that it's there when we're working with NPR, choose, what were we choosing for? The answer is 1,365. We're okay with example 1? On a student council, there are 8 females and 7 males. We want to select a committee out of those 15 people that has 6 people on it. So if there are no restrictions, how many different committees could you form? A committee is a group of people in which the order or the position of each person is not important. So the answer to this is 15, choose 6. Irrespective of whether you get an equal number of males and females or an imbalance or no males or no females, this is how many we're talking about. Getting 5,005. So now things get, they appear to get complicated, but they're not. How many ways are there to select committees if there are 3 females and 3 males on the committee? Well, what do you have to do? You have to choose 3 females and you have to choose 3 males. Bobby Bear had to put on a pair of pants and a shirt. We have to choose 3 females and 3 males. Well, how many ways are there to choose 3 females? That's it. 8 choose 3. Because there's 8 of them and we're choosing 3. How many ways are there to choose 7 males? How many ways are there to choose out of 7 males, 3 males? 7 choose 3. And this is what I mean by don't overcomplicate things. We are using the fundamental counting principle because we have to multiply those 2 things together. But to find each one, don't use the fundamental counting principle. It just won't work. So we have 7 choose 3 times 8 choose 3. I mean, you're aware that the order in which I multiply these doesn't matter. On my calculator, I don't like the spacing on the TI calculator of what things look like. It looks like we're going to have a 24 in here because it's 3 times 8. It's not. Your calculator is smart enough to lock this together and this together. It calculates each of those before it does any multiplication. So what I get is 1960, same thing as you. Okay. There must be at least 1 male. Okay. So don't write this down. What does at least 1 male mean? It means we could have 1 male and 5 females. Correct? Or 2 males and 4 females. I'll just pause after each one to let you sort that out in your head. Or we could have 3 and 3. So what's happening is I'm looking at all of the options, and at least 1 male means 1 or 2 or 3 or 4 or 5 or even 6. So it could be or 4 males and 2 females, or 5 and 1, or 6 and 0. And each of these you can find, right? You okay? Okay, just checking. I mean, I can find 1 male and 5 females for the committee by saying 7 choose 1 times 8 choose 5. I could do that. Or means add, so then I could move on to 2 males and 4 females. 7 choose 2 for the males and 8 choose 4. And I can continue in this fashion, but I hope it's really clear that this is a lot of work. And if it was not 15, not 8 and 7 or 7 and 8, but if it was 22 and 30, there's got to be a better way to do it. This, by the way, works out to 4,997. The way to do it is to recognize that if you have at least 1 male, the only other possibility is having no males. So if we find the total number of 6-person committees, and we subtract from that all of the committees that are just female, every other committee will have at least 1 male. This is like finding how many ways we can arrange the volleyball players so Joan and Emily are not together. We take the total and subtract how many where they are together. So, what is the total number of committees? Total number of combinations, irrespective of male or female. It's 15 choose 6, and we already figured that out, right? I think it was 5,005. Yeah. What is the number of committees with 0 males? It's 8 choose 6. And I want to pause here and add something just to provide a little more detail about that 8 choose 6. It's 8 choose 6 because the males might as well not even be on the list of people at this point in time. You have 8 females to choose from, and you're going to choose 6. If you want, you can say the number of ways to choose 6 females and no males is 8 choose 6 times 7 choose 0. But 7 choose 0 is 1. There's only one way I can choose nobody out of a group of 7. I just stand there and it's done. And that works out to 28. So there's 5,005 different committees. Some of those committees have males. Most of those committees have males. But a select few, only 28, don't. So if we subtract them, you get the answer. D, Jimmy, the president, must be included. So this is a group of people on a students' union in a school, and they're forming a 6-member subcommittee or a committee from those 15 people. So there's 2 ways to approach it. One way is to just say, I need to choose 5 people out of the 14 other people, because Jimmy's already on there. Does that make sense to you? Okay. What you could do is you could break these 15 people into 2 groups, not males and females, but into Jimmys and non-Jimmys. I mean, and if you have to have Jimmy on the committee, that means you need, of the 1 Jimmy, you need to choose 1, and of the 14 non-Jimmys, you need to choose 5. And 1 choose 1 happens to be 1. I'll leave it to you to find out what 14 choose 5 is. Can somebody just tell me what you get, though? 2002. I mean, and I think finding the actual number is important, but it's the least important part of learning what's going on here. Explain why 10 choose 3 and 10 choose 7 are the same. I would like you to calculate 10 choose 3 on your calculator. Owen, have you got 10 choose 3?
120.
120. And have you also found that 10 choose 7 is 120? Why are they the same? So, I need 10 people. Oh, good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everybody in Noah's row and to your right of Noah's row are the 10 people. And I'm going to choose 3 to take for ice cream. And apparently there's 120 different ways that I can pick 3 people to go for ice cream, right? Noah, Mark, and Ben. Noah, Mark, and Caleb. I mean, I could just stand here for a long time trying to find 120 different ways, but it could be possible. It's possible. Why is the number of ways to select 3 people out of this group of 10, why does it have to be the same as the number of ways to select 7 out of the group of 10? Anybody have an idea? Yeah?
I'm not sure, but it's because it's 3 away from being to the maximum of 10, and 3 away from being 0.
Where does the 7 come into it?
Well, 7 is 3 away from 10. That's
Okay, so what you're noticing is that 3 and 7 add up to 10. That's just another way to describe what you told me. That 3 is 7 away from 10 and 7 is 3 away from 10. What's going on here is, let's imagine, and I don't think this way, I'm just using it as a humorous kind of way to learn. Let's imagine that I'm going to choose 3 people to go for ice cream. But really, what's going on in my head is I'm going to pick 7 people that I do not want to take for ice cream. Noah, there's no way I'm taking Noah, right? I'm just kidding around, right? The point is, if I select 3 people to go, I'm really selecting 7 not to go. So for every group or combination of 3 people, there is a group or a combination of 7 people. So if there are 120 ways to remove 3 people from this group, there have to be 120 ways to leave 7 people in the group. And we can easily turn it around and say, I'm going to serve the ice cream in the classroom. So how many ways can I choose 3 people to have ice cream is the same as the number of ways I can remove 7 people from the group of 10. And this only works if these 2 numbers, these 2 r's, add up to give what n is. And sometimes you will see this kind of question. What is P equal to? And it looks like a confusing question. But if you recognize that this, and there's a condition to this question, must be equal to 4, you can solve the problem. Okay. The question would have to say that P is not equal to -6, which is what you would get if you just set 8 equal to this, okay? That would be the condition, because you could actually find the value of P to make it true. So what you would need to do is set 2P plus 20 equals 4 and solve for P. P is not the number that you're choosing, it's just some number. You would say 4 equals 2P plus 20. Subtract 20 from both sides and divide by 2. And you get, I think, -8. Okay. Let's take a look at the next question. Well, I already had this all typed out, but you get the idea here, right? Choosing 3 is choosing not to choose 7, is the way to think of it. And I think maybe we can summarize this without writing down all of this stuff by saying n choose A equals n choose B. If A and B are different, means that A plus B has to be n. That's the bottom line. It's always going to be that way. All right. There are 12 different types of toppings for ice cream, and you want 3 toppings, and because you're not insane, one of them must be chocolate. Okay? If you don't like chocolate, no offense. How many different sundaes could you choose from? Well, it's 3 different toppings. You can't have as much as you might want chocolate, chocolate, chocolate. Okay? You have to have chocolate and 2 other types. But that means the answer to this question is 11, choose 2. Because there are 11 toppings that are not chocolate, and you want 2 of them. If you want to be more pedantic about it, more picky about it, more exact about it, or precise, you could say that of the 1 chocolate topping, you need to choose it, and of the 11 remaining toppings, you need to choose 2. Somebody have what 11 choose 2 is? 75? 55. In a classroom, when each student shakes hands with every other student, there are 300 handshakes. What that means is that the number of students in the class choose 2 has to be 300. A handshake is 2 people making contact. And the order in which they reach out to each other doesn't matter. So a handshake between Ethan and Owen is the same as a handshake between Owen and Ethan. It's a handshake. It's not an arrangement, it's a combination. We're asked to algebraically find the number of students. Well, this will be n factorial over n minus 2 factorial, 2 factorial, using the combinations formula. From a few days ago, you should know that the n minus 2 factorial is contained inside of the n factorial. So to get rid of the factorials, we can expand the n factorial so we can cancel the n minus 2 factorials. And on the denominator end of things, that 2 factorial just is 2, so I dropped the factorial symbol. Gone. I can multiply both sides by 2. 300 times 2 will give me 600. And I can multiply this n in. And now I have a quadratic equation. Given that there is an answer to this question, and it's not some weird, unrealistic situation where we have parts of people, n must be a whole number, right? So that means this must be factorable. I don't know what the numbers are. And let's say you're in the same boat as me. I really don't. I would probably take the square root of 600 and then round up or down and see if those numbers work, because this is a negative 1. But we can cheat the system here. You can put in for y, x choose 2, and just go to our table and find the answer. Find out where this is equal to 300. I'm not going to be looking here at a graph. I'm just going to go to my table, set up my table to, there we go, start at 0 and go up by 1. I'm looking for 300 handshakes. There it is, 25. So I do this behind the scenes, and then I go, well, of course this factors into n minus 25, n plus, I'm going to guess 24. 25 times 24 will give you 600. You take 600 divided by 25. And then you say, oh, okay, n is equal to 25, or n is equal to negative 24. Never mind having part of a person, you cannot have negative people, so there are 25 people. How many different 4-letter arrangements are possible using any 2 letters from the word smile and any 2 letters from the word part? Well, what do you have to do here? You need to choose two letters out of the word smile, don't you? That's something you have to do. So that would be 5, choose 2. And of the 4 letters in the word part, you have to choose 2 as well. That's not going to be the answer. There's something else you need to do. What? It's a classic kind of question. It would be like saying, I have 5 females and 8 males, and I want to select 2 from each group and align them. I don't want to just select 2 from each group. I want to put them in order after I select them. I've chosen the 2 letters from the word smile. I've chosen the 2 letters from the word part. And now I need to arrange those 4 items. So, or I could write 4p4 there instead of 4 factorial. I think 5 choose 2 is 10, isn't it? I'm pretty sure 4 choose 2 is 6. $1,440. All right, a couple more quick questions. How many diagonals are in a 12-sided regular polygon? And I've chosen 12 because it's not easy to draw. But there's a 12-sided polygon. A diagonal is a line connecting vertices, and that line has to be inside of the polygon. Do you understand that there's a lot of lines I could draw here? What's important is we don't try to draw it to answer the question. We say, of the 12 vertices, we need to choose 2 of them to connect. But this is not the answer. Can I get a number on this first, what 12 choose 2 is equal to? No?
66.
66? So if I continued to do this, I could draw 66 diagonals. Sorry. That's not the answer to the question. What this is telling us is there are 66 different ways to connect pairs of vertices, corners. Why is that not the number of diagonals?
Is it because there's 12 ways that you cannot?
Right. There are 12 sides to this polygon, and this that I'm going to draw in, I think it will be blue, this, all of these 12 sides are a pair of vertices. So these 12 are included in the 66. We have to subtract 12. Which gives you 54. There's so many examples, types of questions we do in this unit. You may never see a question like this again in your lifetime. Or it might be on an exam of mine or the diploma exam. How's my subtraction? 54? Okay. So, final question, I believe, 7b. No, there's one more. How many sides would a polygon have if there are 119 diagonals? Well, the number of sides choose 2 minus the number of sides better give you 119. Just like 12 choose 2 minus 12 gives you the number of diagonals. We could solve this algebraically, but we're not going to. Let's go to our calculator and enter x choose 2 minus x and go table exploring and find out where we get 119. 17 sides. And 8. This is a question from a previous lesson. When we talked about permutations, the numbers were different, but I said you have a certain number of seats that are empty and a certain number of people get on. And the answer to this question is 9p4. So before I explain that, take your calculator and figure out what 9p4 is. $2024? 3024. The answer to this question is 3024. And let me just walk you through what I said a couple of lessons ago with a question like this. This doesn't make sense to me. Because when you see 9p4, that tells you you're arranging 4 of the 9 items. And you're not arranging 4 seats, you're arranging 4 people in 9 seats. Do you get the idea that this is weird to think about? So I never do these questions this way. I say, you know what you need to do to answer this question? You need to choose 4 of the 9 seats that the people are going to sit in, and you need to arrange those 4 people in those seats. To me, this is cleaner. This makes more sense to me. Well, you have 9 empty seats. What do you have to do first? Decide on which 6 seats, not 6, which 4 seats the people are going to sit in, and then you have to have a decision as to where everybody sits. So take your calculator and go 9 choose 4 times 4 factorial. You'll get 3024. Of course you will, because the number of permutations of 4 items is 4 factorial more times as many as the number of combinations. So when you see that kind of seat arrangement thing, and it's a typical question on exams, I approach it with the stuff on the left.